If I ask you what 2 plus 2 is, the answer is obvious. If I ask you the square root of 9, also obvious, it's 3. But what is the square root of -1? Stop and actually think about that for a second. What number multiplied by itself gives you a negative number? For centuries, the answer was simple. It doesn't exist. Full stop, case closed. And yet, right now in your pocket, that exact impossible number is running. Your phone, your Wi-Fi, the GPS that got you here. Every one of them depends on a number that mathematicians insisted, for hundreds of years, could not possibly be real. How does something impossible end up load-bearing? That's what this video is actually about. Not really a video about a square root. A video about how an idea nobody believed in became one nobody can live without. Here's the problem in its purest form. Take any number you like and multiply it by itself. The result is always positive. Always, no exceptions. 2 squared is 4. 3 squared is 9. 5 squared is 25. And here's the part that trips people up. Even -4 squared is 16, still positive. A negative times a negative flips back to positive. There is no loophole here, no exception hiding somewhere. So logically, there can be no number that squared gives you -1. It looked like a flat-out contradiction, baked into the structure of arithmetic itself. And for centuries, mathematicians did the simplest thing possible with a contradiction. They just ignored it. Any equation that asked for the square root of a negative number was simply declared to have no solution. End of discussion. For a simple equation like x squared equals -1, that was easy enough to accept. You just say, this equation has no answer and move on with your life. The trouble is, mathematics didn't stay simple for long. Then, in 16th century Italy, along comes a mathematician named Gerolamo Cardano. This was an era when mathematicians held public contests, betting money and reputations on who could solve the hardest equations. Cardano is obsessed with the hardest kind of problem people had at the time. Not equations with an x squared, equations with an x cubed. Cubic equations. He finally works out a general formula to solve them. A real breakthrough. But when he plugs in certain numbers, something strange happens partway through the calculation. A square root of a negative number shows up, right in the middle of the formula. Cardano has absolutely no idea what this thing is. By every rule he knows, it shouldn't be there at all. He doesn't believe it's real. He even calls it as subtle as it is useless. But here's the strange part. He keeps calculating anyway. He treats the impossible number like a placeholder, a ghost just passing through the machine. And when he reaches the final answer, the impossible number cancels itself out completely, and the number left behind is correct. Real, ordinary, verifiable with a ruler. A few decades later, another Italian mathematician, Rafael Bombelli, pushes even further. He writes down actual rules for adding, multiplying, and working with this impossible number. Not because he was sure it existed, but because every single time it kept producing correct, real answers. Mathematicians were now doing arithmetic with a number nobody believed was real. And somehow, it worked every time. Sit with that for a second. How can a number that doesn't exist consistently produce answers that do? A couple of centuries later, Leonhard Euler picks up the thread. He gives the impossible number a name, the letter I. Then comes Carl Friedrich Gauss. And slowly between them, they uncover something extraordinary. This number was never a mistake. It just doesn't live on the number line you already know. It lives in a completely different mathematical dimension. Picture the number line you learned in school. Negative numbers stretching left, positive numbers stretching right. Every ordinary number you've ever used lives somewhere on that single line. Now, rotate that entire line 90 degrees. A brand new axis appears, standing straight up, perpendicular to the first. One axis for real numbers, one axis for imaginary numbers. Together, they form something called the complex plane. And the square root of -1 sits exactly one step up that brand new axis. It was never missing. It was just standing in a direction nobody had thought to look yet. Gauss goes even further and proves something enormous. Every single polynomial equation of any degree has a solution somewhere on this new plane. Not most equations, not almost all of them. Literally everyone, without exception. The broken number system turned out to be the first one that was ever actually complete. And once you can rotate, not just slide, numbers start doing something new. Multiplying by I doesn't move a number left or right. It spins it exactly 90 degrees around the plane. Euler pushes this one step further, into what's still considered one of the most beautiful equations ever written. E raised to the power of I times pi plus 1 equals 0. 5 of the most important numbers in mathematics, locked together in a single line. It links spinning, growth, and circles into a single, impossibly compact statement. A rotation, hiding inside an equation that would go on to describe every wave in the universe. Now here's where this gets genuinely interesting. What would happen if we erased this number completely, deleted it from mathematics, pretended Cardano never saw it? Start with your phone. No Wi-Fi. Radio signals are waves, and engineers describe every wave using complex numbers to track both its strength and its timing at once. No GPS. Your location is calculated from radio signals bouncing off satellites. The exact same math gone. No MRI machines. Medical imaging reconstructs a picture of your body from a complex number signal, beamed out of every atom in the room. No modern electronics at all. Every circuit with alternating current is designed and analyzed using complex numbers, because they are the only way to track a signal that's constantly changing direction. No radar, no sonar. Both work by sending out a wave and reading its complex number echo. No fiber optic internet, and no lasers behind it. Light itself is modeled at its core as a wave written in complex numbers. No digital signal processing. No audio compression, no image compression, no video calls. No autopilot, and no rockets that reliably reach orbit. Control systems keep a plane, or a rocket, stable using complex numbers to predict how it will wobble before it ever does. No quantum computing. The entire mathematical description of a qubit is written in complex numbers. Delete I, and the theory doesn't just weaken, it stops existing. A huge portion of modern physics simply stops working on paper the moment you take this one number away. The impossible number turned out to be load-bearing for almost everything you touch today. This is the moment that should actually give you chills. For centuries, mathematicians called this number absurd. A trick not real, not allowed. Today, it's one of the single most important tools in all of science. Maybe the lesson here isn't really about mathematics at all. Maybe it's this. Some of history's most useful ideas look completely impossible right up until the moment they don't. Reality was never obligated to feel intuitive. Math doesn't always describe the world we can already see. Sometimes it describes a world we don't understand yet, until physics quietly proves it was there all along. The phone in your pocket is running on a number that, for 200 years, wasn't supposed to exist. So here's a question for the comments. If mathematicians in the 1500 could be this wrong about what exists, what impossible idea today might turn out to be true tomorrow? If this kind of hidden history is your thing, subscribe. We go looking for the turning points behind science that most people never hear about. New one every week. Turning Point.